How's it going, gamers? Today we're going to do Leetcode unique paths. So we are given a robot, and this robot can only go right or down. And we want to compute the number of paths this robot can take so that it can reach the star here. So you have controls one out. Let's say the robot here and the stars here. This is example 1 here. How many ways can the robot reach this grid? Only one way, right? Because the robot start here. So it's going to be one way for the robot to reach this grid here. How about this grid? Still only one way, right? Because the robot cannot go down and go right and go up again. No, you can only go right or go down. So same thing here, and also same thing here. The robot cannot go right down and then to the left, right? It's only go right and down. How about this grid? Yeah, if we do it from scratch, we don't reuse the number of ways we know from this grid. We know that it's gonna be two way, right? One way and then go down and right is two ways. But why are we do it from scratch when we already know that there's only one way here and one way here? So for the robot to reach this grid, there's two ways, the sum of these two, right? How about here? Same thing. If we do that from scratch, we can do right down, that's one way, down right, two ways, and down right is three ways. But why are we recalculating everything when we just know that there's only one way here for the robot to reach this grid, two ways here for the robot to reach this grid, so the total is going to be 3. Same thing here. If we calculate from scratch, one way, two way, three ways, and 4 ways, right? But we can reuse the calculation, so it's going to be the sum of the number of ways the robot can reach this grid plus the number of ways the robot can reach this grid. So the sum of the grid to the left and the grid above it is going to be 4. So it's going to be 5, 6, 7 here, and same thing here, 2 and 1, 2 and 3, 6, 10, 15, 21, and 28, and that is the output. So we essentially just recalculating. Instead of recalculating, we are saving the steps in kind of like a table, you know what I'm saying? So it's kind of like a dynamic programming problem, you know what I'm saying? But one thing is that, do we even need to store everything here? Just go back here. When we're calculating this grid here, do we even need to have the entire table to calculate this grid? Or we just only need the result above it and the result to the left of it? So think about it. We might only need 2 rows, right? The one above it and the one to the left. How about with this? How about we only need one row? This is gonna be the same thing. Let's say we only need this row. So the one to its left is 1, and the one to its right, the one above it, is itself, right? And then we modify it in place, gonna be 2 here. How about this one? The one to its left is gonna be 2. The one above it is itself. So this one is gonna be 3. See that? Same thing. So in theory, we only need one array to store the number of ways we can do it. We don't even need 2. We don't even need the whole table. Yeah, so let's code up. Let's have a vector of the size of the columns. That's gonna be n. So we can call this vector db. The size is gonna be n. The initial value is gonna be 1, right? Because the first row we've refilled it to be 1. It's gonna be 1 anyway, regardless. And then what we're gonna do is we're gonna do a for loop, just a simple double for loop, I think. And yeah, for each row, each column, essentially. So we're just gonna do that real quick. Less than n plus j, and we can start at 1, right? Because look at this, we start at this 1 and 1 grid here. So we already prefill these two to be 1s, right? Which is essentially just this entire array here with db here. So we can start at 1, and then what we're gonna do is gonna compute the number of ways we can reach this grid j. That is, here are j, right, the columns. So this grid here is what I'm trying to say is the one to its left, which is gonna be j minus 1, and the one above it, which is gonna be itself, and itself is gonna be 1, right? So this one is gonna be 2 here, and that is essentially the calculation. We can do that for the entire row and columns, right? And once we found the final row, the result is going to be stored in the last value of that row, right? So simply return db of the last value is n minus 1, because the size is n, right? And that is the entire solution. Let's run it. Oh, oops, missing a j here, my bad. Come on, run again. Right, submit. And that is unique path. Thanks for watching, guys. See you guys next time.